Hello, we're Team Pi-3. I'm Matthew Kyle.
I'm Hemant Vikash.
I'm Anuj Roy.
And I'm Brett Pomerantz. So, our team was given the task to develop a Rube Goldberg machine that will, for K through 12th grade, that will show conservation of energy. And so we chose 4th grade because they go over kinetic and potential energy. And so we developed a machine that would demonstrate the transfer of energy. So as you can see, each of our team members made one design in a total of 4. We chose the 3rd design, which you can see here is a CAD model of it. It is basically a cylinder that has a spring and a ball inside. The kids will be able to decide how far to pull the spring back to try to get it into the funnel here. When it goes into the funnel, it will roll down the ramp and it will gain some kinetic energy like that.
So here you can see our Gantt chart, which we used to plan our project and set dates for when we wanted to complete things. So as you can see, we finished parts A and B, which was the identification of the customer needs and the establishment of our target specifications. So these steps have been completed, and these are most of our planning periods. And so now we are in the process of designing and making sure that our concepts are fully generated. And so as you can see, we are on C, which is the intellectual properties and literature research, and we are about 65% of the way through. Down the line, we will be doing a development stage where we will be testing our design and making sure that it works perfectly so that we can show it to the children and have them understand how the conservation of energy works.
For customer needs, the ping pong ball must enter and exit the Rube Goldberg at the same speed of 3.4 miles an hour. And our Rube Goldberg machine must fit on a 2-foot by 2-foot board. For our customer profile, we did it on Dr. Kim Lester. She is head of the outreach programs here at Virginia Tech for the SEED office. She's also a former teacher, and some of the specifications she gave us were it should show friction at one point on the machine where kids can identify it, and the kids should also be able to identify one point on the machine where the ping pong ball has kinetic energy and one point where it has potential energy.
So as far as our customer specifications go, we took into account some of Kim Lester's specifications and as well as our other customers who we pulled. We found that they wanted to understand the basic principles of physics, specifically conservation of energy from potential energy to kinetic energy. And we wanted to use video software in order to do this. So if we were to record the system of the ping pong ball going through the machine, you could actually see that the potential energy is equal to the kinetic energy at multiple different points. Apart from this, we also wanted the device to be easy to use so that the students could use it and understand how it works outside of the classroom even, or just in activities. And we also wanted it to be engaging so that the students enjoyed actually watching our machine show the conservation of energy throughout.
This is the QFD chart, and it shows the relationship between the customer requirements and the engineering characteristics. And the customer weight is the scale in which shows the priority of the customer, and it's from 1 to 5, with 5 being the highest. And these are the correlation numbers, and it starts from 1, and 3 is the highest on the chart. And the correlation numbers basically show us how much the customer needs and the engineering characteristics are related. So if you see here, exiting at the same speed will be closely related to the particle motion demonstrator, but not exactly going through the obstacle course. So we have 3 for exiting at the same speed and 1 for going through the obstacle course. And the escape velocity is the most correlated one with the engineering characteristics. So that is definitely given the highest priority.
Here's our economics. We decided on a price of $250 initially for the Rube Goldberg, and we used a scenario 2 model. So after each machine, the price will go down. So if they wanted to buy 10, each machine would be cheaper than if they only buy 1. We decided to give them a 50-cent discount per each machine that they buy, because it would give them incentive to buy more. And for our cost curve, we had the initial cost of $11,250 to help pay for equipment, and we decided that the Rube Goldberg machine would cost around $50 to assemble, so for each Rube Goldberg manufactured, we'll have an additional $50 cost. Our first break-even point is between 67 and 68 Rube Goldberg sold. Our second break-even point is between 332 and 333 Rube Goldberg sold. And our optimum value for profit is selling 200 Rube Goldbergs, which will give us a profit of $750, $8,750.
So to sum up, we are the basic mission behind this project is to teach the 4th grade students about the kinematics and conservation of energy. And as far as our Gantt chart is concerned, we are complete with the planning period, and we are more into the concept generation period. And the customer, with all the expectations of the customers filed, we can definitely go into the research of the project. And the optimal units that we like to sell would be 200 units with a profit of $8,000 something dollars.